In this video, we will talk about how to find the domain of logarithmic functions. So I have three examples here of log functions, and we're asked to find the domain of each function. Before we do that, it helps to actually understand, what does the function y equals log of x? What does that look like? Well, it has the following basic shape. Something like this, where the values that we're allowed to plug in for x range from greater than 0 all the way to positive infinity. So when we have a log function like this, it means that the value that we plug into the log function has to be greater than 0 in order for us to get a valid output for y. So let's keep that in mind as we're working through these three examples. So this first example says y equals log base 2 of x. What would the domain of this function be? Well, all we need to know is that this value x right here, whatever is inside these parentheses, it has to be greater than 0 in order for us to get a valid y output. So all we would say is x needs to be greater than 0. That's our domain. Or if we wanted to write it in interval notation, we could write it as 0 to positive infinity. And we write it with parentheses to indicate that 0 is not included in the domain, so we're not allowed to plug in a 0. It has to be greater than 0. So the domain for this function would range from 0 to positive infinity. All right, let's check out this second example. We have y equals log base 3 of x plus 5. So once again, our domain, we just need to make sure that whatever is in these parentheses inside of the log function, it needs to be greater than 0. So what we can say is x plus 5 must be greater than 0. Now to solve for x, we can subtract a 5 from each side, and we'll get x has to be greater than negative 5. Or if we wanted to write that in interval notation, we could say from negative 5 to positive infinity. That is the domain of this function. And what we'll find is if we plug in a value that's in this range, so let's say an x value of 0. If we plugged in a 0 right here, we would get 0 plus 5. So log base 3 of 5, that's a real number that will produce a real number for y. So that's a valid input. But if we put in something less than 5, so if we put in like a negative 10 right here, we would get negative 10 plus 5, which is negative 5. Now, the log base 3 of negative 5 is not a real number, so it wouldn't produce a valid output for y. So that's our answer for this one. X has to be greater than negative 5. All right, let's check out this last example. We have y equals log base 5 of 6 minus 2x. So once again, whatever is inside these parentheses, it needs to be greater than 0 for our domain. So what we can say is 6 minus 2x must be greater than 0. Now to solve for x, we can subtract the 6 from each side. So we get negative 2x must be greater than negative 6. And to solve for x, we can divide both sides by negative 2. Now, when we have an inequality and we divide by a negative, we have to flip the sign right here. So we would get, when we divide this side by negative 2, the negative 2's cancel out and we're left with x is less than, so we're flipping the sign, negative 6 divided by negative 2 is positive 3. So x has to be less than 3, or written in interval notation, we could say x can range from negative infinity all the way up to positive 3. And we'll use a parentheses once again to indicate that 3 is not included in the domain. So that's our answer for this one. And we'll find that if we choose some value in this domain, so let's say a value of 0, if we plugged in a 0 for x right here, we would get 6 minus 2 times 0 would just be 6. So the log base 5 of 6, that's a real number. But if we were to plug in, let's say, a 4 for x, which is outside this domain, we would get 6 minus 2 times 4. So 2 times 4 is 8. So 6 minus 8 is negative 2. So the log base 5 of negative 2 is not a valid value. So that's just kind of a way to double check yourself. So those were just three different examples of how to find the domain of log functions.